Hi, welcome to Cybersecure channel. I extend my apologies for delay in publishing new videos due to some personal commitments. I am thankful for your support and comments during this tenure. Continuing with CKS Exam Essential, curriculum outline is broadly divided into 6 domains. In September 2024, some changes have been made in curriculum and associated domain percentages, which are flashed on the screen. In today's video, I will cover topics from third domain, which is system hardening, having 10% weightage as per September 2024 format. This domain covers minimizing OS footprints, minimizing identity and access management role, minimizing external access and kernel hardening. Today, I will be discussing minimizing identity access management roles and external access. While taking stock of Kubernetes architecture, we observe that at the bottom there is host operating system, which itself should have certain level of security. Then we have Kubernetes Cluster built on top of the operating system that runs as a process. At the top we have application, which comprises of pods and containers that run on Kubernetes. In order to maintain a consistent, secure state, principle of defense in depth needs to be followed, focusing on reducing attack surfaces through least privilege. Each security objective is achieved by implementing various measures in the respective domain. Today, as part of domain 3, we will be focusing on the operating system. The first objective of defense in depth is obtained by implementing the concept of authentication, authorization, admission control, and auditing on each focused area. Authentication is confirming user's identity, while authorization is defining what user can do. Admission control can be validating where action of authorized individuals are checked against preset rules, or mutating where some changes are made to the object as per defined criteria. In the end, we have audits to keep track of things. To reduce the attack surface, we need to remove some unnecessary packages, stop unwanted services, terminate redundant processes, and delete malicious binaries. Stock taking of installed software and services are essential to ensure that unwanted programs are not installed and vulnerable services are not exposed for attackers. It is also important to be able to identify all open ports and their associated services and binaries in order to remove unwanted items if required. Packages are archives containing precompiled binaries. Command to display installed packages and to remove them is shown on the screen. Services are programs that run in the background. To start or stop a service, the command is flashed on the screen. The network ports are communication endpoints. To view active listening TCP ports, the shown command can be used to display them. Processes illustrates active execution of programs, while binaries are executable files on the Linux. Command to kill process and delete binaries are shown on the screen. Managing access control is crucial. The goal is to ensure that right people have the right access to the right resources and all the actions of the users are recorded for audit purpose. Specific command for implementation of this control are flashed on the screen and will be demonstrated next. Now coming towards the live demo. In live demo, we will run previously mentioned command to minimize IAM roles in external access. First, defining the right people by configuring the group. We will create a group admin, then creating a user SAM and assigning the group admin to it. Now, after assigning, then we configure the password for the user. The default home directory and shell path of the user can be seen. Now changing the home directory first. And then assigning non-interactive shell to the user, which means the user cannot SSH to the system. This configuration is normally used for service account where such access is not required. Now confirming the no login command. Now coming towards the write access, we created a file. Now let's change the ownership of the file. First of all, checking the ownership. And now changing the ownership to the SAM user. We can also change the ability of the owner and group to read and write and execute the file while keeping read-only access to the other users. Now coming towards the write resources, we can make the same account sudo by making changes to the sudo file. Further, we can also make changes to SSH configuration by not allowing the root login or public key authentication setting as required. We can check the audit logs to check which user used the sudo command. The logs can be checked to display the use of the sudo command. Now coming towards the end, today we implemented some operating system feature to minimize IAM roles and external access. I hope you found this video useful. Please subscribe to remain updated. Thanks.